Okay, and now we're on to part B. So part B, we're just going to confirm what we supposed would be the case by inspection. And part A, we're actually going to calculate the magnitudes of the net magnetic field at both points, and we should see that one should be greater than the other. So let's first consider the field at A. So we can say that this B is the sum of the two fields B1 and B2. And that's and now if let's assume a direction. I'll say that out of the page is positive and in is negative. So in this case, both of them are coming out. So we'll look at the magnitude as being positive. So this is gonna I'll just be adding. I've got mu naught I1 over 2 pi. We've got R1 and R2 with the same value, so let's just call it R. And I've got mu naught I2 over 2 pi r. I can factor out the mu naught over 2 pi r, and then I've got I1 and I2. Since r mu naught's not negative, or it's a positive value, r can't be negative. The only one, if I am establishing a direction, I'll talk about the current being positive or negative. But since both of these fields are coming out, I'm going to assume that I'm going to use the positive values for both of these currents. So I'll just plug them in. So I've got 4 pi times 10 to the power of minus 7 Tesla meters per amp. And that'll be divided by 2 pi times 16 centimeters, or 10 to the power of minus 2 meters, all times what was 6.2 amps positive plus 4.5 amps positive. Again, because the positive, assuming the positive direction, because I'm going to have a positive result. And when you work this out, we should get a value of 1.34 times 10 to the power of minus 5 Tesla. Okay, now let's look at the field at B. Okay, again, we'll use the same argument. B, the resultant field is the field due to current 1 and the field due to I2. Yeah, I'm going to shortcut this because we're going to get the same thing, mu naught over 2 pi r times I1 plus I2, but the thing is, for I1, the field is going to be into the page. We said that negative, so we'll use negative I1 plus I2. Right, so this will give us a negative value for one of the fields, a positive value for the other, because one's into the page and one's out. Now we substitute all the numbers in, so 4 pi times 10 to the power of minus 7 Tesla meters per amp, all over 2 pi times 16 times 10 to the power of minus 2 meters times negative 6.2 amps plus 4.5 amps, and I'm running out of space here, and I get a final value of, that'll be negative 2.13 times 10 to the power of minus 6 Tesla. So accounting for the fact that one's out of the page and one's into the page, but the field at A still has a magnitude that's about an order of magnitude higher than at B. So the proof is in the pudding, and the numbers show exactly what we assumed would be the case in part A. And we'll see you for the next question.